Good morning. In continuation from the previous class, let us see today's topic, that is the combinational logic. So first to start with, the combinational logic definition. Combinational logic gives combinational logic is defined as the combination of or combining basic gates into circuits that performs desired functions. Here, the basic gates meaning it may be an AND gate, NOT gate, NOR gate, or OR gate, etc. The other way of defining this combinational logic can also define as the logic circuits that contains no memory element, or logic circuit that does not contain memory So the meaning of memory is for storing information is called the combinational logic. Either of the two ways we can define the combinational circuit or combinational logic. After knowing the definition for this combinational logic, the combinational circuits, how do we represent? Generally, these combinational circuits logic circuits represented as through a functional block diagram as a block consists of n inputs represented as x1, x2, etc. xn produces m number of outputs. So these m number of outputs we can represent as y0, y1, y2, etc. yn. And here x is an input variable which consists of x1, x2, x3, x4, etc. to xn, and y is an output variable representing y0, y1, etc. up to yn. Yn are, in simple terms, y is a function of x variable. This is how you can represent a combinational cell. And if you are observing, and this particular block, it is an combinational logic. And here, if you observe the relationship between the output and the input, there is no feedback. This is very important. There is no feedback exists between output to input. Hence, it is termed to be an combinational logic or combinational circuit. Further moving on to the relationship between output and input. How do we correlate? Is correlated or represented either as equations or truth table, or it may be through the logic diagrams. So whatever it is, either equation you take or truth table you take or logic diagram you take, it will have the inputs as well as the outputs. When you take the truth table specifies the input state that tells output true or false. So this is how you can define the truth table. Or when you go for a switching equation, which are derived from truth tables. Further, using these switching equations, we can realize using the basic gates, So this is the importance of switching equation. So now let us see, after knowing the definition of an combinational logic, now further we will see how do we illustrate how truth tables are developed, simplified, and logic circuits are derived using different techniques. So as already we know that in a combinational circuit, the outputs and the inputs either they can be derived through the truth tables or through the equations or through the logic diagrams. So therefore, in any combinational logic, if the equation has been specified, what will be the next process in designing the logic circuit, or if a truth table is given, how will be it? And if it is a logic diagram, how then design of logic circuit. Sometimes it need not be equation or truth table or logic diagram. Sometimes the combinational circuit may also represent in the form of statements too. So in such cases, how do the conversion process, complete conversion process we will be doing? So that is what we will be discussing next.